Okay, guys, let's talk about balancing an equation in BASE. This is problem C from number 8 in worksheet 11.2. And there is something missing, so that's one of the reasons I picked it, is they did not indicate that there was water present. And we have to have something over here with hydrogen in it. If you're ever in doubt, put water. Because most of our reactions are going to take place in water, so it's likely it can be a reactant. So when we have this reaction, oxygen here in NO3 is going to be 2 minus. Here in NO, it's 2 minus, and here in H2O, it's 2 minus. So oxygen has not changed oxidation states at all. But I know that nitrogen had to, because it's in a different bonding environment. It has a different number of oxygens attached. And hydrogen went from being an element to being in a compound. So I know it's changed as well. So I'm going to look at H2 going to H2O. And the first thing I look at is the number of atoms of hydrogen are balanced. I don't care about anything but hydrogen in this reaction. And here the oxidation state for oxygen is 0, and here it is a +1. And so one hydrogen lost 1 electron, and the second one lost 1 electron. So it lost a total of 2 electrons. So to make this equal, I need to add 2 electrons on this side. And so this is my oxidation reaction. Now looking at NO3 minus going to NO. Since this is -2 in almost all compounds except for if it's with fluoride, then this must be +2. This one I'm going to figure out. So to figure it out, x plus 3 times a -2 equals -1. So x minus 6 equals -1. So x equals +5. So this went from +5 to +2. It means it must have gained, and I'm just going to erase my work so I have more room over here. It means it must have gone from +2 to, or from +5 to +2 means it gained 3 electrons. And I have to have electrons as both a product and as a reactant, or my reaction won't work. And so I have to have 1 reduction and 1 oxidation. But I have to transfer the same number of electrons. So I'm going to have to go to 6. So I'm going to multiply the top equation through by 3. So I'm going to put a 3 here, a 3 here, and I'm going to make that 6. And I'm going to multiply through by 2 here. So this will be 6, 2, and 2. Now when I add up these two equations, my electrons cancel out. And so I have 3H2 plus 2NO3 minus. And I try really hard to keep my arrows lined up so I can keep my reactants and my products on the correct side. Then 2NO plus 3 H2Os. Okay, now I know nitrogens and hydrogens are balanced, but oxygens are not. So let's see how many we have. I have 6 oxygens here. I have 2 here, plus 3 here is 5. That is not the same number. I need more on this side. And the only way to do that is we typically add hydrogen to balance H's. So let's look at H's. They've got 6 here and 6 here, so those are good. Then the next step after you add hydrogens would be to add water to balance oxygen. So I need to add some water over here. I need 1 molecule of water. But now that's going to mess up my hydrogens. So I added 2 hydrogens here. So I'm going to add 2 hydrogen ions over here. Now that I've got my hydrogens back in balance, since this is in base, I can't have hydrogen ions. So I'm going to add hydroxides to both sides to make them equal. or to get rid of those 2 hydrogen ions. So I want to get rid of 2 hydrogen ions, so I'm going to add 2 hydroxide ions, and this would make 2 molecules of water. And if I add 2 hydroxides here, I'm going to add 2 hydroxides over here. Now I have 2 water molecules here. I have 4 over here. I can get rid of that one and one of those to get rid of both of those, just to make it into like the lowest possible terms. So my ending reaction, all balanced, would be 3 H2s plus 2 NO3 minus yields 2 NO plus 2 H2Os plus 2 hydroxides. The last thing we have to do is check to see if the charges are the same on both sides. They have to be equal. And it's kind of a double check to make sure you didn't do something stupid. So here I have a -2 charge, and here I have a -2 charge, so I'm balanced for all my atoms. I balanced my electrons. And then I balanced and made sure the charges were matched. And so all of those 3 things are good. And so I have a balanced equation. So what are the steps? So 1, you do your reduction. 2, you do your oxidation. You can do those in either order. 3, then you balance atoms in those 2 reactions. Then you balance electrons in those 2 equations. We have to transfer the same number of electrons. Then you're going to add up. And then typically what you have to do at this point is you have to balance hydrogens. And to balance hydrogens, you add H ions. And then you're going to balance oxygens by adding water. And if that's it, you're done. If you're in base, so if you're in acid, you're done here. And you can do these 2 in either order. And then lastly, if you're in base, you add OH to both sides to change H plus to H2O. And so you may end up then with hydroxide as a reactant or as a product. In this case, it ended up as a product, and that's totally fine. You just have to have, if it tells you base, you should not have hydrogens left over. You should have converted them to water and have hydroxide somewhere in there. So hopefully this is helpful. I'm going to do another video on oxidation numbers in just a minute. So let me know if there's anything else you need. Just drop me a note via email or however you want to get it to me, and I will put them up as soon as I can. Thanks for watching.